Hello friends, how are you? I hope you would be fine. Today my topic is about model predictions and control. Okay, the learning objectives are in the previous chapter we assumed that the model of the MDP dynamics be available in many of the applications. The MDP model is unknown but can be sampled, or the MDP model is known as but is computationally feasible to use. Except for the through sampling, in this case, the agent needs to learn the model from the sample interactions between the agent and the environment. In this chapter, we will address the sample-based learning, which requires only experience, sample sequence of states, actions, and rewards from the interactions through typically reinforcement learnings. Upon the completion of this chapter, you should be able to understand and implement MC policy evaluation, first visit and every visit understanding, and implement the TD learning for policy evaluations, understand the state action function Q of SA evaluation for policy control, compare and implement the function policy control iteration algorithms, MC method, TD of 0, TD of gamma, TD control, SRSA, SRSA of gamma, and Q learning. Monte Carlo policy evaluation. Let's consider Monte Carlo MC policy evaluation. Its goal is to learn state value function V pi from episodes of experience under policy. Pi is S1, A1, R2. SK, the return is the total discounted reward for the episode ending at T is greater than T. Gt is equal to rt plus 1 plus gamma, rt plus 2 plus so on, yt minus t minus 1 rt. The value function is expected to return v pi of s is equal to e pi gt st is equal to s. The mg policy evaluation use sample average return instead of expected return, since a state may show up multiple times in one episode, so there are two types of MC policy evaluation methods. First visit and every visit. For the first visit one, the return of for the state S is updated only for the states first show up for an episode, exercise that thereafter show ups in the episode will not result in the update of return. On the other hand, the every visit one will update the return whenever the state shows up during an episode. First visit MC on policy evaluations. Initialize N of C is equal to 0, G of S is equal to 0 for all S is belongs to S. Loop for each episode, sample episode size at SI1A, I1, R1, I2, SI2, AI2, RI3, AI, TMI minus 1, RIT, SITI. Define GIT is equal to RIT plus 1 plus gamma RIT plus 2, thus gamma square RIT plus 3 as a return from time step 1 to the end of the episode for each state visited in episode I. If S is visited at the first time in episode I, increment counter of the total visit first visits n is equal to n plus 1. Increment total return G is equal to G plus G. Update estimate P of S is equal to G of S by NS. Properties can be improved that the estimator V pi of S is an unbiased estimator of true EGT ST is equal to S by law of the natural law in numbers as n of S infinity. Every visit MC on policy evaluation initialize N of S is equal to 0, G of S is equal to 0 for all S belongs to S. Loop for each episode, sample episode I S AI 1 RI2 SI2 AI2 RI3 AITI minus 1 RITI SITI. Okay, for each state visited in episode I. For every time the state is visited in episode I, increment counter of total visits n is equal to n plus 1. Increment total return G is equal to G plus GIT. Update estimate V pi is equal to G of S by ns. Okay, so I think this is enough for today's topic. Time to go. Goodbye, meet you in the next video.